In this problem, we have an airline who doesn't want its employees to use drugs. The airline hires a lab to do drug testing. The lab's drug test is 94.23% accurate, but it has a false positive rate of 5.9%. In the community where these employees are hired, there's only 1.48% of the people in the community, who happen to be drug users. And the airline just did a drug test, and 111 of its employees just popped positive for drug use. So we're going to go through and analyze this issue and show how drug tests can result in a large number of people being falsely terminated. So the first question is, given a randomly chosen employee as a druggie. So what we're doing here is we're saying, if you could gather a bunch of drug users together, give them this test, we want to know what the probability of that person testing positive for drugs is. And all that is the drug lab's accuracy rate of 94.23%. So imagine a drug lab has this drug test. They want to know if it works. They find a place where everybody's a drug user, and they give those drug users this test. According to their test, 94.23% of them will test positive. So some don't test positive. So, which is what this answer is. So given the people are druggies, what is the probability of that drug user testing negative for drug use? So you have to take 100 minus 94.23, which is 5.76999. So we're going to copy this right here. So that would be 77. And we'll go ahead and hit enter to see if we got it right. And we got them both right. Okay, now next question. Given a randomly chosen employee is clean, so what is the probability of that employee testing positive for drugs? Well, that would be, they're clean, but they test positive. That is the false positive rate of 5.9%. We'll type it as 5.90%. Given a randomly chosen employee is clean, what is the probability of that employee testing negative for drugs? Well, that's 100 minus 5.90, or 94.1%. How does the drug lab come up with this? Well, it's got to find a group of people who they're pretty confident are free of drugs. And then they give them the test, and 5.9% of them test positive, and 94.10 test negative. Excuse me. Now, what is the probability that an employee is a druggie? Well, we're going to assume that because the employees come from the community and the community prevalence rate is 1.48%, we're going to assume that is the probability that an employee is a druggie. What is the probability that an employee is clean? Well, that's just 100 minus that value, right? Or 98.52%. And we'll go ahead and see what we're doing. We'll hit enter. It looks like we've got everything correct so far. Now, using Bayes' rule, compute the probability an employee is a druggie given the employee tested positive for drug use. So this is a slightly different question, isn't it? We want to know, given you have all these employees that test negative and you got all these employees that test positive, of those employees that tested positive, we want to know what the probability is that they are druggie. So we're going to use Bayes' rule to do this. So here's an equation we're going to use. We know the probability of druggie, that is 1.48%. We know the probability of clean, that is 98.52%. We know the probability of a positive result given the person's a druggie, that's 94.23%. And we know the probability of a positive given the person's clean. So given the person's clean, what's probably they test negative? Well, sorry. Given a randomly chosen person is clean, what is probably the employee tested positive for drugs? That would be this value here. So we're going to first calculate the numerator. And the numerator is a probability of testing or being a druggie, which is 0.0148. We divide the 1.48% divided by 100. We divide it by 100 to give us the decimal version of it. We're going to multiply that by the probability of testing positive given your druggie. So given your druggie, what's probably testing positive? 94.23. Again, we're going to change this to a decimal, not a percent. And that's the numerator. Notice that this value here is this value here. So now all we need is what? The probability of clean. So I'm going to get the probability of clean here. And the probability of clean is 98.52. But I want to again convert it to decimal. I'm going to multiply that by the probability of testing positive given you're clean. So given a randomly chosen employee is clean, what is probably the employee tested positive for drugs? 5.90. I multiply that and I get that value. And I'm going to type equal there. So now what do I have to do is I have to take this, I got to divide it by the sum. Actually, I'll do this. Sum of this. And I get, let's see. I need to turn that to percent. And I get 19.35. 19.35. So let's just think about that. The probability an employee is a druggie, given the employee tested positive for drugs. We're talking about all the people that tested positive for drugs. And most people think, well, if they tested positive, they're probably guilty, right? But according to Bayes' rule, of those people that test positive at this company, only 19.35% are actually drug users. Let's hit enter to see if we got it right. And we did. Now we want to find, using Bayes' rule, the probability an employee is clean given the employee tested positive for drugs. Well, to calculate that, we just have to take 100 minus 19.35, which is 80.65%. Okay, so what does that mean? So you have all these people that tested positive for drugs. If there's 100 people that tested positive for drugs, 80.65% of them are clean. So if you terminate everybody that tested positive for drugs, you're actually firing more people who are clean, in this case, than the people who are actually drug users. So now we want to know how many drug-using employees were fired for failing the drug test. Okay, remember, 111 of the employees tested positive. So I'm going to put that right here. Right? 111 of them tested positive. So 111 druggies, right? Or 111 positive drug test. Right? 111 positive drug tests. How many drug-using employees were fired for failing the drug test? All we do is we take this, we got to divide by 100, times that. And we get to zero decimal places, 21 employees. 21 of those 111 who tested positive were actually drug users. Minus that. So we have 111 positive drug tests times this divided by 100. So 90 of the 111 positive tests were actually clean employees. So if you use this drug test in this particular situation, you're falsely terminating 90 clean employees, and you're correctly terminating 21 drug using employees. And we got everything correct.